So, what I will do now, we will use the same data set to understand the severity of this problem. That means, how two-step estimation can make the standard error downward bias. So, let us go back to our statistical software, and then we will be using both difference and system GMM to understand this downward bias. So, we will be again using the same data, we will use AB data, right, and then the model what we are going to estimate is xt upon 2 dependent variable in, then L1 L dot n, sorry, L dot n, and then L 0 by 1 dot W1 k, and then we have ER specific dummy, and then within GMM we can have only L dot n, right, and then IV is YR star and then equation level and then let us take robust. So, what we are doing here in this model, we have not specified any two step. So, that is why we will be getting one step difference GMM, because we have taken equation level also, right. I think we need one more bracket over here. So, what we have estimated? This is basically we have estimated, look at one step system GMM, right, because we have given equation level also, right. The moment we import equation level, that means both difference as well as level equation are considered, right. This is one step, and what is the coefficient? Coefficient is 0.92, and 0.92 means, as you can recall, it is lying well within the interval of 0.74 and 1.04, right. So, that criteria is fulfilled. Okay. Now, if I go for two step without any Windmeyer correction, so we will not be putting robust. So, if we go for two step, then I will not put any robust command, just I will put two step, right. Okay. So, when I put two step, then what is my coefficient? Coefficient is 0.94, which was earlier 0.92. Now, I will compare the standard error. This is 0.06, but look at this is 0.03. Okay. So, when I put two step without any correction, then I am getting 0.3, right. So, what I are saying that this two step estimator 0.94 is more consistent compared to the one step. Both of them though lying within the interval, but this is downward bias. Okay, this is downward bias. You can see this is 0.038, earlier this was 0.6. So, compared to this, this is less. So, 2-step is downward bias. So, what we will do now? We will put 2-step and also robust, and then you see what is happening. Now, the standard error become 0.0624, which was earlier 0.03. So, again it has come back, and if you compare, this is 0.0696. So, it is almost like that 0.0624, almost like the 1-step estimation. So, we have gained consistency, at the same time we have corrected the standard error, asymptotic standard error of the 2-step estimator. Who suggested this? Windmeyer suggested in 2005 paper, Windmeyer correction. Okay. So, within the system GMM estimation, we showed that 2-step GMM, if we apply, then standard errors are downward biased. To correct for that, we need to put the robust command, even though the coefficients are actually more or less same compared to the 1-step, right. So, whenever we are applying 2-step GMM, we must put that robust command to correct for that bias, right. Now, we will apply the same model in the context of difference GMM, and then we will see what is happening, right. So, let us put xt upon 2, xt upon 2, and then in and L dot in and capital L 0 by 1 and then W dot W and K. These are my exogenous variable, also wire star, and then I have GMM. Within the GMM I have L dot in only, then I have IV, where I have earlier specification was little incorrect because I have not put anything on W and K. So, IV is W and K, and then we have YR star, and we have if it is difference equation, then what we need to put is that we do not need any level equation, no level, and then no level robust small. So, basically what we are estimating? 1-step difference GMM, right, 1-step difference GMM. Okay. So, when you are estimating 1-step difference GMM, what is happening? My coefficient is 0.63, that means my coefficient is not lying within the specified interval. So, 1-step difference GMM could not ensure that my estimate lying within the theoretically defined bound. Now, there might be many reasons for that. We should not blame only on one step or two step. Firstly, what we are doing here in the specification, you see I have considered only one period lag of that employment variable as endogenous. I have not considered second or third order lags. Here also for W and K, I have considered one period lag, and then I have not considered industrial output proxy for demand. Here in the IV accordingly, I have not considered WL1, WL2, KL1, KL2 and all those as instrument. So, this could be due to the specification of those variables. For the time being, I assume that this entire reduction in the coefficient is due to the one step system difference GMM, right. If I do level equation, if I take level equation, that means the same specification with level equation, whether it will give me an estimate which will lie within the interval, let us see. See, one step system is ensuring the coefficient is lying there. So, while one step difference GMM could not ensure the estimate to lie within the interval, one step system GMM ensured. Now, what we will do? We will take the same system difference GMM only, but we will try to put two step. Same specification, but we are going for two step difference GMM to understand how much difference it makes to the GMM estimates as well as its asymptotic standard error if we go for two step discussed earlier. Let us see. When I put two step also, then the difference GMM is not actually able to ensure my estimate to lie between the theoretically defined bound. So, whatever might be its standard error, I do not bother. First of all, my estimate must lie within the interval. Since it is not, then what I can do? So, that means if you compare the standard error, it is 0.08. Earlier when we have estimated this model, this is look at 0.17. So, one thing is very clear that two step estimator standard errors are severely downward by almost 50%. Look at here 0.17 and here it is 0.08. That means almost 50% reduction in the standard error. So, what we should do now? Here in two step, let us put the robust command. Robust is basically triggers the Windmeyer correction in the standard error. What is happening? Even though my estimates are still not lying within the interval, at least my standard error is increased. That much I could ensure, right. So, while two step GMM estimators could ensure almost both the estimates of system GMM, that means when we have estimated system GMM, I will go back once again to what we have estimated. So, this is two step system GMM, coefficient is 0.94 lying within the interval. Before that we have estimated one step GMM, coefficient lying within the interval. So, that means both one step and two step system GMM ensured the coefficient lying within the interval, right. So, what we can write that here what is our finding then? Both both one step and two steps system GMM estimators ensured that the value of the estimator lie within the theoretically set bounds given by OLS and FE. Okay. So, that is our finding. So, both one step and system GMM, they ensured the value to lie within the interval. Then next, what we have estimated? We have estimated two step GMM with robust command, right, to ensure that two step GMM without robust command, it is sorry, this is without robust command, that means this is a downward bias in the standard error. Then we estimated the same two step system GMM with two step correction and we got back the standard error in its previous value. Then what we did? We did difference GMM one step, and what is the value? 0.63, not within the interval. Then we estimated GMM again one step, but with robust command. Sorry, this is a one step system GMM again. Sorry, this is lastly two step difference GMM, the value is not within the interval, right. So, both one step and two step, this is one step difference GMM, this is two step difference, earlier one was one step difference. So, none of this difference GMM model could ensure that my value lying within the interval. I will read out once again. This is two step difference GMM, value is, so I will write two step difference GMM, two step difference GMM, two step difference GMM value equals to 0.60. So, 0.60. Then what is the previous model before that? This was the last one, two step difference GMM, and before that what we have estimated? Two step difference GMM with robust command or not? Okay. And last one, two step with robust. So, two step difference GMM with and without robust equals to almost equals to 0.60, that means could not ensure the value to lie within the interval. okay, within the interval. Now, what you can do? You can actually then the change the specification. That means, here I have considered only L dot n as my endogenous variable. Now, if I change that, if I change the endogenous variable, then will you get any difference? So, that means xt upon 2 in this command itself within GMM, what we can do, that L dot I can write in, and then I can consider W also, then K also, and then we will see whether, sorry, I should have this bracket closed. See, now the estimate almost lying towards 0.70. So, that means it is approaching towards the limit. The moment I change that, so that means every possibility while estimating the model, every possibility we have to check whether this coefficient what we are getting, is it due to one step, is it due to two step. If it is two step and then it is satisfying the criteria, it is lying within the interval, what we need to do is basically to correct the standard error, just to put robust command, right. Secondly, even after doing all this, if nothing is working out, what we need to check? We need to check whether the specification of GMM style and IV style instruments, they are correct or not. If it is not, then we can change it, the variables which were considered as exogenous earlier, now we can consider some of those variables as endogenous, but all this modification should not be done on randomly, it should be based on some theoretical argument. Here I have a strong ground to consider W and K as endogenous, because some theory says that labor supply and labor demand curve, they interact, and that interaction gives equilibrium level of wage and labor. Similarly, labor employment and capital, they also, there is a simultaneity because of the reverse causality running from employment to capital. That is why I can use those variables as endogenous. But if you do not have such kind of theoretical background, you cannot simply add those variables in the GMM style, then the reviewer of your paper will ask question why you have considered those variables as endogenous. So, exogeneity and endogeneity should come from a theory or your own logic, it should not be randomly selected. That is what I pointed out. So, then I would like to summarize today's discussion, that basically what we learned, there are two variants of GMM estimates, one step and two step, both in the context of difference and system. The basic difference between why we go for two step, because two step is more consistent and its standard error are actually, it gives the heteroscedasticity and autocorrelation adjusted standard error, that hack standard error, because in dynamic panel data model we have already assumed there might be heteroscedasticity and autocorrelation within the individuals, but not across. If that is the case, we need to have a standard error which is consistent with this heteroscedasticity and autocorrelation, and if that is the case, two step estimators are preferable to one step GMM estimator. But two step estimator, while giving you extra consistency, they come with some cost. What is the cost? The cost is some kind of bias in their asymptotic standard error. So, whenever we go for two-step GMM estimation, we must correct for that bias in their asymptotic standard error. And that asymptotic standard error, the bias in that asymptotic standard error is corrected given the suggestion by Windmeyer 2005, that is the paper I referred to in today's discussion. So, if you apply that, then you will get two-step GMM and automatically it will correct for your downward bias, because the bias might be severe. As Arellano and Bond said, that this bias could be so severe that it cannot be used for any inference making, right. So, if you feel, and then what we did, we simulated different types of model to understand the sensitivity of our estimate towards one step and two step in the context of both difference and system. While system GMM, when we applied two step, what is the finding that we got? Both one step and two step system GMM ensured that the value lie within the interval. But when we have applied the two step in the context of difference, then with or without Windmeyer correction, it could not ensure that. So, that means two step GMM estimation is always good. That type of perception we should not carry over, because it is not the case in case of difference GMM. Downward bias is automatically corrected by robust command, but first of all what we need to check is whether the estimated value is lying within the interval. If that is not lying within the theoretically defined bound, then it is of no use. That is why we could not take this two-step difference GMM. But at the same time, what we said, that we cannot blame everything on the difference GMM method, because the moment I changed the specification, some of the variables which were earlier mentioned as IV style, the moment I brought them into GMM style, the quality of the estimator improved a lot. So, we have to play around with all this specification until and unless the value lie within the interval. Once it lies within the interval, then we will correct for its standard error by the Windmeyer correction given by the robust command in data. So, with this we are closing our today's discussion. Thank you.